had network issue. That's why we've not been going live. We are supposed to start this class by 8 o'clock. We are having serious network issue. We just say, let's just try it. If you check the last class I did on gas pressure, we were not even, people were complaining that they could not see whatever we were writing on the board. Now let's discuss this topic in the next 30 minutes. Now, gas pressure. Gas pressures are made up, let me say gases generally are made up of what? Molecules. And these molecules are in random motion. And when they are in random motion, what happens? They collide with each other and with the walls of the containing vessel. That means the wall of the container. And when they collide with the wall of the container, what happens is that they now exert pressure. That pressure that is exerted is what we call gas pressure. Now, what instrument is used to measure gas pressure? The instrument used to measure what? Gas pressure is known as manometer. So manometer is an instrument used to measure what? Gas pressure. Now let us draw a simple diagram of how gas manometer is. Let's just draw a sketch of how gas thermometer is. Let's say we have something like this. Now, whenever you are using a gas thermometer, what we use one liquid to what? In gas or in manometer. The liquid used in gas thermometer or in manometer, is 1. Please take note of that. Whenever you want to use manometer, which we call a U-tube shape instrument, is what we call manometer. Whenever you want to, this also what we call a simple what kind of manometer, the simplest you can have, because we can have a complex one indeed. Now, in working this, the gas will be here. Don't forget that a gas will supply pressure to the tube, and the tube will have a what? A liquid, and that liquid is what we call manometric liquid. The liquid used is what we call manometric liquid. The condition for that liquid is that you must ensure that that liquid has a high density, to ensure that we can measure a very high pressure. So if you want to measure high pressure, it's better you use a liquid with high density. That means a manometric liquid of high density. Don't forget, I told you in the use of manometer to measure pressure, we use what they call only one liquid. But if you want to use it to measure relative density, we use two liquid. Now, don't forget that liquid that you are using here must be immiscible. Must be, that means it must not become, the liquid should not be able to mix with other liquid for proper analysis. Now, let's say we have a liquid here inside the manometer. Now, don't forget that the manometer is exerting pressure. It's exerting pressure on the liquid. There is an atmosphere also here. We call it atmospheric pressure. The atmospheric pressure also exert a pressure. Now, something happened here. Now, let's take a case 1. A case 1 is a case where let the gas pressure be greater than the atmospheric pressure. Or let's take a case where the two are equal. Now, if the pressure exerted by the gas to supply the liquid inside the U-tube is the same as the atmospheric pressure that is supplied by the atmospheric pressure, or the pressure that is supplied by the atmosphere. Now, what will happen is that the level of the water or the liquid in the tube will be the same. Don't forget, let's say we use water now, for instance, it becomes a water manometer. Don't forget, the name of the manometer will be based on the name of the liquid that is placed in the manometer. So we call this one a water manometer. Now, why do we call it a water manometer? Because it is water that is found inside that we use as our manometric liquid. Now, the better one should be what? We have mercury manometer. I think that one is better than water. Why? Because the density of liquid of mercury is higher than density of water. So preferably, I will choose mercury manometer because it has a higher pressure. And don't forget, for the manometric liquid to produce high pressure, means that you can measure high gas pressure. Don't forget, we can measure high gas pressure. Now, as I was saying, if the atmospheric pressure here is supplied by the gas, or that means the gas pressure supplied by the gas and the atmospheric pressure supplied by the atmosphere are the same, that means that there will not be difference in the level of the water on both sides of the U-tube. There will not be that means the height will be equal to zero. The height will be equal to zero. That means in that case, the gas pressure is equal to the atmospheric pressure. In this case, the gas pressure becomes 760 millimeter of mercury. Now let us take a case where, let's look at case 2. Case 2, I didn't start this class on time, but I will try to finish the analysis. Let's say the gas pressure is greater than the atmospheric pressure. The gas pressure, let's say, is greater than the atmospheric pressure. What will happen is that because the gas pressure is higher than the atmospheric pressure, it will push the liquid up. It will push the liquid up. Now to a particular height above particular H above the above the level on this part of the pressure. Now, what do you notice? You will notice that the level is no longer the same again. The level on the part of the atmospheric pressure is now higher than Now, what causes the height to go up? Don't forget that because the pressure of this atmosphere is smaller, the height will have increased. Now, the height brought about decreasing the atmospheric pressure here, and this one now will help to increase the pressure. That's why the gas pressure that as it supply the pressure higher than the atmospheric pressure, it pushes the liquid up above the level on the part of the gas. On the U-tube, there are two sides. The side of the gas will not be lower than the height on the side of the atmosphere. That means the gas pressure becomes the atmospheric pressure plus pressure due to the height that has been created. Now, don't forget that we use plus because it was higher. We use plus because anytime gas pressure is higher than atmospheric pressure, is addition we consider. Please, very, very important to know that. So that is to say, will be the density of the water. Density of the water. Most of the times they can give us this density of water of the atmosphere. That means in millimeter of water. Then plus this one will not be used as just normal H. That means they can give us H in form of the atmosphere plus this height. Right? You will get gas pressure. So gas pressure, sometimes the height, the pressure can be expressed in terms of height. You are going to see that how it works. Now, don't forget that manometer can be used to measure relative density. But listen, the liquid that will be used there will be two. One will be reference liquid. Most of the times, the reference liquid or the standard liquid that is used is water. Then the other one would be unknown liquid. The unknown liquid can be alcohol, can be any liquid at all. So note that when you use a manometer to measure gas pressure we use one liquid. But when it is used to measure what do you call it, relative density, we use what, two liquid. Now I've explained this one. Now don't forget that rho GH of what, of the mercury, that means the pressure of the mercury can be equal to the pressure of the water. So sometimes you might need to use this formula to convert what, this mercury, because atmospheric pressure is what, in form of mercury. So you can convert the mercury pressure to water pressure using this formula. So you can get your H, which is that of water, to be what, rho what mgh of mercury, this is mercury, divide by what, density of water, gravity of what, acceleration to gravity, which we can cancel this one. Can we cancel here? Yes, this one can be cancelled. Then we are going to have what, the pressure in terms of water, which can be what, H in terms of millimeter of water, should be equal to what, density of what, mercury, times what, H of mercury, divided by what, density of water. So with this formula, you can actually convert your density in what, millimeter mercury, to what, millimeter of water. Now let's go to what, case 3. Now we are able to establish that in case 2, when the pressure is higher than the atmospheric pressure, there will be an increase in the height along the arm of the what, the side of the, or the tube side of the what, the atmosphere, the right hand side. This is the right hand side. Now there will be a rise in the height of the what, liquid, the manometric liquid, on the part of atmospheric pressure, because what, it gives what, a lesser pressure compared to what the gas involved supplied. Let's look at case 3, which is the last case I'm going to look at tonight, and we'll look at question because time does not permit us to do more. I think I've tried for simple manometer. What we're going to look at now, in the case of what, when the gas pressure is lesser than what, than the atmospheric pressure. What will happen whenever the gas pressure is lesser than the atmospheric pressure? Let's look at that. Let me use my hanky because we don't have this here. Use it so that I can quickly finish the class. Now look at the board. Now look at this gas thermometer. Now I want to use the case of this. Let's just look at this gas thermometer or gas manometer. Now in this case, now the gas is here supplied to the liquid. Now this liquid, now let's say supply what, a gas pressure to the liquid. Now because the gas pressure supplied a lesser pressure, look at what will happen. Now look at it, very important. It will even help you for those of you in A level too, because when you talk about fluid mechanics, apart from physics, it also applies. I mean, a simple manometer before you now go to complex one. Now let's see. This is atmospheric pressure now. Apply. Now this pressure exerts more pressure than the gas. Now because it exerts more pressure than the gas, there will be what? This one will push down while this one will rise up. So that means the what? The height here is what we call H. So there is a drop in the height on the part of what? The what do you call it? The atmospheric pressure. Why there is now increase in the height on the part of the gas pressure? So what will be the gas pressure? Well, again, gas pressure is equal to what? The P atmosphere of the water of the atmosphere minus. Why are we using minus? Because the atmospheric pressure is now higher than the gas pressure. So if there will be a drop, that means there is a drop in the gas pressure. That means the gas pressure is smaller than the atmospheric pressure, because in this case now the gas pressure is smaller than atmospheric pressure. In this case now the gas pressure is what? Higher than the atmospheric pressure. See where we use plus there in the first equation. But in the second equation now we are using which is rho G what? DH. Let's say it's mercury they are using now, for example. If it's mercury now, so it will be direct straight. Density of mercury, gravity of mercury, the accelerator to gravity normally, then the height of the mercury on that particular U2. So it will be minus here. Now I've talked about a case where the two sides are the same. That means I've given a case like this before, where we have what the two sides the same, where the gas pressure exerts what equal pressure as the atmospheric pressure. For those of you that are just joining us, if the gas pressure is the same as what the atmospheric pressure, then it will be the same, no increase in the height, and the h there is equal to what? 0 millimeter, depending on the unit that is being used. But in the case where the gas pressure is higher, it will push the U-tube on the arm of the atmosphere higher. Then when it's what the gas pressure is what lower than the atmospheric pressure, it will push the manometric liquid higher on the part or on the arm or on the side of the U-tube of the gas, because this side is for the gas, is for the atmosphere. And don't forget that what we use more than one liquid for manometer when used to measure what gas pressure. And I've told us also how gas can exert pressure. Gases are what are made of molecules, and these molecules are in random motion. Random motion in physics we call it a zigzag motion, whereby what they exert pressure with one they exert pressure as a result of colliding with each other, and also not with each other alone. They exert pressure with the container itself, the containing vessel. And that vessel now, by the time they exert pressure on the containing vessel, that brings about what we call the gas pressure. And we have also talked about that the gas pressure can be measured with a manometer. Now, the manometer liquid that is used, that is the manometric liquid of a manometer, is what we name it to be. If we use water, we call it water manometer. If you are using mercury, we call it what? Mercury manometer. And the liquid that we use will decide the kind of manometer we are going to use. And majorly, most importantly, what we use now to select our manometer is the pressure and is the density. We must ensure the density is low. If you go to some authors, some textbooks, they will tell you must have low vapor pressure. They will say you must use an immiscible liquid, so and so forth and so on. They will even go as far as telling you low surface tension. But I've given you the most important one, which is density, which is visible to what we can analyze here. Don't forget, the higher the density, the higher the pressure of the water. So if you want to measure a high pressure kind of gas molecules, you use a liquid with high density. What I would recommend is a mercury a manometer. But when you want to measure a low pressure gas pressure substance, maybe you want to measure gas pressure with low pressure, then I will require you to use water manometer. So we have also talked about that, and we give you various condition, different condition. This is what case 3 that I've just given. That when the pressure of the gas is less than pressure of the atmosphere. I think that was what I did in case 3. This was case 1, which when the case they are the same. This is case 2 when the gas pressure is higher, and this is case 3 when the gas pressure is lesser. Now let us take question. I think so that we can know where we are and what we have done so far. Let's take question. I would like to take question, even though it's 2 questions before we go. It is important to take question. So when we come the next class, and what I will do is to take question on pressure, all kind of question on pressure. So that next class will be calculation on the pressure. We have done so far, so that we will now look at application. I think the only part that is remaining for us is application. Now let us look at this question now. Quickly, I will draw the diagram quickly, so we'll look at it. Now this is the diagram given to us. They give us G as the gas, and we are given what? A liquid. And that liquid goes on and on, goes on and on, even above the what? The level of the gas, the liquid on the arm of the gas rather, which is this part. So they gave us from here to this part to what? As what? 10 centimeter. Then they gave us here as what? As 3 centimeter. Now don't forget that when you want to solve question on what? Relative density. This one, relative density will be equal to what? Density of the liquid over density of water. So in this formula I gave you last, somebody else can say, Mr. Holiday, what if I bring the what? The mercury under, and let's have something like this. Okay, let's say mercury is our liquid now, the unknown liquid, and water is the standard. Now let's say we want to now find relative density of mercury. Now let's take what? The height in form of this in form of density. What about in form of height? It will be what? Dense height of water over height of what? Of mercury. See, please take note of that. This is what we call the specific gravity. Sometimes in A level, we use it as what? As gamma. So that is relationship between density of mercury and density of water. Don't forget that relative density is defined as density of what? Of liquid over density of water. Then in terms of height, now be what? Height of water over height of the liquid used to calculate what? Density. In case you want to convert the mercury to any other liquid, or depending on the liquid that is used on the manometer. Now let's take this one. I say in the diagram above, if what? The atmospheric pressure is 760 millimeter mercury. Full stop. The gas pressure on the what? The chamber G is dash. The gas pressure on the chamber is dash. Now what we are looking for now, we are given a diagram. G is the what? The gas. This is the chamber. The chamber of the gas. Now, if you check very well, if I should ask you, those of you that are watching us live now, which of these, is it the atmospheric pressure that is higher, or the gas pressure that is higher in this case? If I may answer the question honestly based on what we have discussed, I think this one is concerned with case 2, where the gas pressure is higher than the atmospheric pressure. If you check a push, any side that has a push of the what? Of the manometric liquid higher is where we are going to have the what? Lesser pressure. That means at this point now, because of this height, tends to reduce the pressure of the atmosphere. Don't forget, the increase in height because what? Decrease in pressure. If you check the relationship between what? Density and pressure is direct proportionality. That means increase in pressure will lead to increase in what? In what? Density, but increase in pressure will lead to decrease in height. Now, because of there is a decrease in height, now what we are going to have now is that because of there is increase in height of the part of the U2 that is what exposed to the what? The atmosphere, therefore the atmospheric pressure will be less. Now, since or will be lesser than what? The gas pressure. And if it's lesser than the gas pressure, the formula to use is that the gas pressure become in the chamber G, because what? Atmospheric pressure. We are giving atmospheric pressure as what? 760 what? Plus what? The height what? Due to what? Now we cannot use density times gravity times height. Let us use what? H. Yes. Let's use H. Because they gave us what? The atmospheric pressure in terms of what? Height. I told you they can give in terms of height. So that's where you now use this one to solve. Now, what is this H? Now, that we are going to have. H will now be 7 from what we are seeing now. Don't forget that the ATM is equal to what? 760 millimeter. Now, the H now, give it to us now, should be equal to what? 10 centimeter minus what? 3 centimeter. How do I know? From here to this place should be 7. Because from here to here is 3. From here to here is 10. So here will be what? 7 centimeter. So here will now be what? 7 centimeter. If you convert it to millimeter, what do? You multiply by what? 10. So we're going to have 70 mm as our what? Our what you call the H. So to now solve the final answer, to get the final answer, what we're going to do is to what? To get the gas what? Pressure. The gas pressure in millimeter will now be what? 760 what? Millimeter plus what? Plus 70 millimeter. Don't forget to convert centimeter to millimeter is multiplied by 10. Reasoning by what? If you check the relationship between what? That means what we say is that 10 centimeter is equal to what? 100 millimeter. Let me check. Now, don't forget that this one is simply as 10 times 10 raised by what? Minus 2, which is what? 0.1. Now, if you check this one, 100 times 10 raised by minus 3 is equivalent to what? Over 1,000, which is what? Also what? 0.1. So that is just that. So to convert what? Centimeter to millimeter, just multiply by 10. That if you check the difference between the two of them, it's just multiplication of 10. So that is just that. So you multiply by 10. What you are going to have is what? 760 plus what? We have 0.38. 830 millimeter. That's what you are going to have as the gas pressure. 830 millimeter. Let us see if you can take another intelligent question across. Now, let's just look at this one. Very important. Now, this one is case 2. Case 2. This one is talking about case 2 before I will now look at case 3 and all that. Or it's talking about this last case. Now, they have a gas here. Now, this is the what? The manometer. This is a manometer. Now, if this is a manometer now, don't forget it must be very, very uniform. It's a rough sketch. A very uniform. Now, let's assume that this place now, according to this question now, look at it. Now, they gave us here as, they said, if the here is H, if the what? The atmospheric pressure is question 2. If you check this question 2 now and question 1, they are not the same. If you check question 2 now, on the part of the okay, I think they are the same. This one is the same. If I change this one to what, they are the same. Let me increase one and make this one go down. I think this one is better now. Now, let's have it this way. Now, this is what? The height of the word. Now, if they give us like this, and I say what? If the word atmospheric pressure is 760 millimeter mercury, what is the what? The gas pressure. What is the gas pressure on the manometer? On what? A manometer. Shown above. Now look at this question now. They are giving us what? They gave us here to be what? They give us here to be 80 millimeter And they gave us here to be what? 10 millimeter. Now, in this case now, what we're going to do now is that, don't forget that this one now, the gas is what? The gas pressure is smaller than what? The atmospheric pressure. How do I know? Now, check the height of the what? Of the water rise of the manometric liquid. It favor, the rise is on the side of the gas pressure. Why this other one, what? It doesn't rise on the part of the what? The atmospheric pressure. Don't forget that this open end, one side is open, one side is closed. It's enclosed with the gas. Now, the part that is enclosed with the gas, it rises is what? In height. There is a rise in height of the part that is enclosed with gas. So in this case, the gas pressure now should be equal to the atmospheric pressure minus what? What? Pressure due to the what? The height. Why do I minus? Because the gas pressure should be less than the what? The atmospheric what? Pressure. So it should be minus. That is the case 3 that we discussed. Now, what we're going to do now in this case, now get your height. Your height due to what? Height is equal to pressure due to what? The height, which is equal to what? Is equal to what? 80 millimeter minus 10 millimeter to get this H. Yeah. So, and that will give us what? 70 mm. So if you get 70 mm, that one is there. What about what? Pressure of the atmosphere is equal to H of the what? Of the atmosphere, which is equal to what? In this case now, they give us a 760 mm. That means now after we have been given that, let's calculate the what? The gas what? Pressure. So the gas pressure is equal to what? H gas, which is equal to what? H of the gas is equal to what? H of the ATM of the atmosphere minus what? H of the what? Due to what? The height. So this is due to height. Now, what we're going to have is 760 what? Mm of this mercury minus what? 870 mm. So in this one we are using minus. The other one we use plus to solve. After we check, we use plus to finalize it. Now this one what I want to have now is what? I want to have what? 690 mm. If you do your calculator, use your calculator, you are going to have that. Then I will solve the last question for the day. I don't know if time will permit us to do that. This is already 9, but let us see whether we can do that. This is already 9 on the dot. But although they're in the house, they're already signaling me for me to round off for today. So, but let us see whether we can solve this question. Let's take the last question. The last number 3 question. Now, in this case, now they said the water what? Manometer. Water manometer in the diagram below. Water manometer in diagram below is necessary, or is measuring rather, measuring the pressure of the gas supplied, full stop. That's what they give us. And that's okay. Say what? If the specific gravity of what? The atmospheric pressure of specific gravity of mercury, is 13.6, and the what? The atmospheric pressure is See, the atmospheric pressure is 70 centimeter of mercury. You see what? See, what is the total pressure of the what? The gas supply in centimeter of water. Now they gave us the diagram like this. So the diagram given to us. Now this diagram, we have what? Liquid, yeah, and there's a rise. Sorry for this one. There's a rise here. Now from this place to this place is 3 centimeter. So that means what they use here is water. And what they are giving us is what? Mercury. So what they give us in the question is mercury. More or less like mercury. So but what we are going to use is what? We want to find in what? This is a water manometer. And in this case now, for what I'm seeing, because the gas here, this is the gas pressure. According to the information, yes, they indicate that's the gas pressure. Now, for what we are looking at, this is the gas pressure now. First is higher than what? The atmospheric what? Pressure. For this side to rise first. Once you know that one, you know it's what? Plus that we are going to use. Number two, what kind of liquid is used here? Is water. I told you how to convert. Now, the conversion mode will not be what? You use the formula, a density of what? Mercury times gravity times height of mercury is equal to density of water times gravity times height of water. We need the height, so, and that height of water will be what? Our equivalent to what? The height of the water. That means the height of water now, not this height, please talk about that. Is the height of water will not be equivalent to what? To the height of what? Water in centimeter of what? Of water. That means the atmospheric pressure of the water. So that's what we want to use now. Now, what we want to do now, we want to convert the mercury to what? To the mercury height to water height. Now, because what we are giving is not mercury manometer, it's water manometer. So now, sometimes we can also use what? Convert the relative density to what? To what? Or specific gravity is also known as what? Relative density. Don't forget. This also apply to A level self, because sometimes they can give you what? Something like that. Now look at the board. Now what I want to do now is convert this one to what? To density by multiplying by what? By 1 gram per centimeter cube, and that will give us what? 13.6 gram per centimeter cube. We have converted by multiplying by what? This is for mercury. Density of mercury times what? What is gravity? Gravity can cancel out gravity. Then what about the height of what? Of the atmosphere due to this mercury is what? 70 centimeter. Then what about the density of water? Is 1 gram per centimeter cube times what is the height of water? We have what? Unknown. Now what we want to do now is to what? To solve for that. Once we can get that now, it is very easy. So what we are going to have now is solve for what? Height of water becomes what? In centimeter of water. Give us what? 13.6 times 70 divided by 1. So what I want to have is what? 0. Then, okay, let's say we move this one now, because 136 times 7, you have what? 955 cm of water. So that means that this one is what? The height of what? Due to atmosphere of what? Is now what? 955 centimeter of what? Of water. So that is the height now that we will consider, because we are using water. So we have converted it. I told you that is you can use the height as the pressure of the atmosphere. Now look at the board. Now after getting that, you have gotten that one now. Now what is our H normally from the diagram? H due to the height of the what? Of manometer. Due to the height of manometer, we go to the YouTube directly. Now, if you go to the YouTube with the manometer to draw, giving to us, you will notice that this is the height now. That is 3. So that height is given us as 3. And don't forget, it's water that is inside. So it tallies. You cannot use this 3 to add to this one. Or not add it to. You know why? Because this is mercury. And what we are giving is what? Water. You cannot use mercury to solve for water manometer. No, you rather convert the mercury to water. You convert the mercury to water. That's why, so if you see some author, they will say they will not even convert to density. They will use specific gravity times what? Height of mercury. Or specific gravity of water times height of water. It's still correct. If it's used that way, it will be correct. So in that case, what I want to do now is we have gotten what this one will now be 3 centimeter. Don't forget the height is 3 centimeter. And they say we should find our total what? Pressure of the gas in centimeter. So just forget about this. And what I want to do now is what? Height of the gas is equal to pressure of the gas, which is equal to, now because the gas produces a higher pressure, it becomes what? H of the what? The ATM plus what? H of the what? Due to the height in the manometer. So what I want to have now, I want to have it as what? 955 plus 3. 955 cm plus what? 3 cm. So what will not be our answer? The answer will not be what? 9 what? 5 what? 8 what? cm of what? Of water. That will give us our what? The gas what? Pressure. In what? Centimeter of water. Don't forget they told us centimeter of what? Of water. That will give you your final what? Answer. Although you can decide to what? To solve other means, other method, but this one is the fastest what? Method to solve this what? This particular what? Questions. I don't think it will stress you too much. So to solve this kind of question, don't forget, ensure. Please help us to find this when you multiply this one. Let me see. Let me confirm that one. 1 3 what? 36 times 7. What do we have? We have what? 2 carry what? This one will give us what? Let's say 5. Go carry 1 4. Okay, sorry. This is 2. Sorry, this one should be 952. I almost make a mistake there, please. So this one now is 952. This one should be what? 955. I think that is better. Because if we multiply, this is 42 now. 42 carry 4. This is 21 plus 1. 4, 5, 25. This is what? 952. I made a mistake there when I'm multiplying. So that one is clear now. 952. Then add the height of the what? Due to the pressure of the gas greater than pressure of the atmosphere. This is atmospheric pressure. This is the pressure of the gas, which is higher. The pressure of the gas is higher than pressure of the atmosphere. Don't forget it's water that is used, so you convert. And I told you how to convert. You use this one. Check the theory video. You use that one to convert to water. Since it is water that is used in the question, they did not say mercury. They only gave you mercury to be able to use it. They give you the height of the mercury. They have given you density, relative density, which is specific gravity. You can convert it. Then when you convert it, use it to convert to water. So whatever you are getting here is synonymous to the pressure, the atmospheric pressure in centimeter of water. And that's what I've done there. So the atmospheric pressure in centimeter of water. That's what we have gotten. And after doing that, don't forget this formula actually relates to depth, not height. Hello. In reality, this formula is depth, not height. So somebody else, but you say height is not proportional to pressure. Yes, I say that. So this idea you are seeing now is assumed to be depth. Don't forget, pressure is proportional to depth, but inversely proportional to height. Note that anywhere in the world is like that. So I have tried my best to what? To analyze this class, and we have been able to cover a little bit of the time wasted. Solve 3 questions, I've analyzed gas pressure. So in our next class, we'll be seeing more on calculation in what? Pressure. So we'll just take some calculations, some common calculations in A level and in O level that are common to what? To this topic. Thank you very much. My name is Engineer. I appreciate you. Thank you, Lord. Thank you for joining us in this video. And please note that we don't just don't do live class. But when we have a network issue like that, it is not, we cannot be teaching when you at home is not seeing what we are doing. So it means that it's an effort wasted, effort in futility. So that is just what we are trying to what? To avoid, to make sure that every single thing we are doing here, which is the message is passed across to the student. Because if you are teaching and you are not seeing it, it means that we are just wasting our time. So that's why you see us not going live sometime when the network is bad. But please click the notification button so that anytime we go live, you just notice that Engineer has gone live and you quickly join us immediately. Thank you very much for joining us. God bless you.